Howdy guys, how are you? Hojo here, or Dooobs, either way. I'm just doing a two-part series, possibly three, I'm not sure yet, on the AStar algorithm. I've built a couple of implementations in it through C#, and I've had some interest from people, and they wanted to know how it works, and yeah, just the basic idea. So first part will just be covering how it works. Second part will be showing a demonstration of the actual algorithm at work through a program I've built using a library that I've made as well. So the library can be used for doing the algorithm itself, and I've built an application around that displays and has like a GUI sort of functionality, so you can see what's actually going on. But anyway, let's get going. So basically here I've drawn a couple of pictures on how it works, just explaining everything. The green is the start node. Each of these tiles is a node, or tile if you want to think of it as a map. Yeah, green is the start, red is the finish. White is a walkable tile. In this case, we'll just say that to walk from here to here is one step. So these are just one steps. And the blues tiles here are non-walkable, so you can't walk on them or progress through them, if you will. Right, and explaining the numbers, the top left corner here, that's what's called the G-score, and the G-score is the distance, the shortest distance from the start node, which is the green one, to the current node. So for example, this tile here has a G-score of 1, meaning it takes one step to go from here to here, and you know, pretty self-explanatory. So 3, you've got 1 step, 2 steps, 3 steps, and that's pretty much it. And this score up here, that's called the H-score, or heuristic value. It's pretty much an estimate from the current node to the finishing node. Now in these pictures I've actually used the Manhattan distance, which is simply nodes left, or nodes on the x-axis and then nodes on the y-axis. So in this case 3 in this tile here, so you go 1, 2, 3, and that's basically it. It's pretty basic, and I'll show you in the second part what the heuristic values do and how they change the path that's formed. Finally, this number down here is the F-score, which is basically just these two scores added together, and that's kind of what we use in the algorithm, but I'll explain that later on. Now these numbers here, the ones in grey, that's got nothing to do with the algorithm as such, but I've put them here to make things easier. That's the sequence in which the tiles are progressed and discovered. And now these blue and dark blue lines, again, it's just a pictorial representation of what actually happens behind the scenes. So if it's a light blue line, that's the first tile that's that's been progressed in from the current tile. Kind of doesn't make sense, but say for example here, number 8, it's discovered this one first, so that's a 9, and then it's discovered this one second, which is a 10. So you know, this is the 8th step, and it goes to 9 and then to 10. So it just shows you which way the algorithm's going, and really it doesn't really matter either way, but that's just how I've drawn it, and you're just going to have to accept that. Alright, so what is AStar? AStar is a pathfinding algorithm. Can be used in many applications. For example, the GPS street maps, like you know, for your GPS units in cars and whatever. You give it a start destination and an end destination, and it'll show you the path. Typically the shortest path possible, although in most GPSs they just do weird stuff, so ignore that. But you can use it to find the shortest path, or just a path in general, and it's really good, and it's, you know, pretty reasonable. There are other options, but I just like the idea of AStar, so that's what I've kind of gone with. My intended use is for a bot for a game. You're progressing through maps that you don't want to record paths in, so you can use this to work out paths, so you don't need to program stuff in, which is, in my opinion, really beneficial. So you can go to unknown places in a game and track through the map from, you know, point X to point Y, and, you know, handle obstructions, you know, like tiles that you can't walk on, monsters that are moving, and yeah. So what happens? How does it work? So basically what happens is you put in the start point and the end point, and you calculate these values. So it's pretty much just a counter, and it counts up. So 1 here, and so you start here, it progresses here, it calculates this score here, the H score, which is the Manhattan distance, which I mentioned before, and it calculates that, and it adds them together and puts this number here. Now what this will do, this is only a 4-directional algorithm, you can do 8 or more, whatever. So it'll go here, it realizes that it's a wall that it can't walk on, so it ignores it, and it'll go down here. And so you go down here, create these values, and then this will become the current node. And then from here you do the same thing again, look for the surrounding tiles, it'll go back here, realize that it's already been progressed through, so it'll ignore it, check here, it's a wall, can't walk there, so it goes down here, realizes it's walkable, and it puts in the values, and again calculates the H score, 1, 2, 3, 4, and then 2 steps from the initial node, and then creates this F score. So basically what happens is that after every node you've got a list of all the tiles that have been progressed through so far, and the algorithm selects the tile with the smallest F score. Now in this map there's only one path and there's no real way to progress anywhere, so of course it's going to go here, can't go anywhere else, so this is going to be the smallest score, and it just keeps going through like this until here, and here it progresses to this tile, creates this tile, and so now here you've got 2 ways to go, but because this number's the same, it's just going to go for the first one on the list, which happens to be this one, and it'll progress, go to the finishing tile, it realizes it's the last tile, and what you've got is a list of tiles or nodes that give you the path from the start to the finish. Of course, if there's a wall here, it would go through, realize there's a wall, and stop.